Welcome back. This will be part 2 of the integral. It'll be a somewhat more complicated function that we're dealing with, but I think you'll be able to fix it anyway. We'll need to use some of our trigonometry knowledge in order to fix this, but it should be fun. So let's take a look at the problem we're dealing with. It says we need to find the area that is bound by the x-axis, or the x line, and the function sine squared of x from 0 to 2 pi. And of course, as always, you've heard me say it a million times, is visualize it in your head. What does sine squared x as a function look like? That's the first place to start. So let's take a look at it. There we go. It might be hard to see all the little numbers down there, but what we have, obviously 0 there, here's pi, and there's 2 pi. In order to fit the whole thing in, it would have been a little difficult to get them all in there, but there we go. We have 2 peaks, and then we're going to find the area of all the stuff under the curve and bound by x. Okay, so straightforward as usual. Then the devil's in the details, as they say. So let's see what we can do with this. All right, there's when we fill it in. That's the area that we want, the green little mountains there. And we know the curve. So what we're going to do is write out the integral the way that we're supposed to. So we're going to be using this here, from 0 to 2 pi, the integral of sine squared x. Okay. Now, at this point in the beginning of the course, you don't have directly the ability to convert this into an antiderivative. So we're going to take a little sidestep there, but not a problem, because in trigonometry you've learned some identities. So you won't see this instantly, but I do have a little thing where you can pause if you don't see which identity I'm using, and you'll be able to just study it out for a little bit. All right, here we go. If you don't see it instantly, just pause right now and work it out. We have before talked about the identities of, in this case, the cosine of 2x is equal to this. And we have part of that right there, okay? And when you rearrange it algebraically, you end up with this for just the part that we had right here, okay? And that is what we then replace with what we had before. So this green box here converts into that green box before we've done anything. But we need to put it into a form that we can handle at this point. Later, we'll get more tools and we'll be able to do some other things. This is just one of the things that we can do. Okay. Once we have that, it's kind of a piece of cake. You know how to do the antiderivative of a half, and it's real easy to do the antiderivative of cosine 2x over 2. So let's get that done. And then we'll analyze, of course, from 0 to 2 pi. Now this becomes a real piece of cake. It's not a problem at all to do this. Some of you have probably already figured it out. But let's go through the motions here. Okay. When we analyze it, 2 pi divided by 2, okay, that's the 2 is obviously going to go out. All that's left is pi. And then the sine of 2 times 2 pi, or 4 pi, that, remember from the unit circle, I'll just doodle real fast here. Remember where it is. It's right here. That's where 2 pi is, where 0 is, where 4 pi is, and so on. So it's real easy to calculate such things in your head.